Check. Cool. Thank you, Gershom. All right, how's everybody doing this afternoon or this morning? I don't even know what time it is right now. It's good. So, good session so far. Everyone learning some stuff? Good. Yeah, thumbs up. That sounds good. Okay, cool. Today I am going to talk about a concept called generative agents. You heard a little bit about this from Kevin this morning. Shovik also talked about some of the components of agents. I'm going to go a little bit deeper into some of the offerings that Google has around agents in our Vertex AI space. And if we have time, I'm going to go into a demo, and hopefully we can get Q&A going. But if we don't end up having enough time, find me afterwards. We can chat and we can do all those things. Cool. A little bit about myself. My name is Patrick Marlow. I am a staff engineer on the Vertex Applied AI Incubator team. That's a mouthful. What does that mean? My team works directly inside of product engineering, so we build a lot of the things that you were seeing showcased today. So a lot of the large language model conversational products or search products, we work a lot on those. We also do a lot of adversarial testing against our models, a lot of incubation with clients and things like that. So I like to say that my job is to, basically work at a startup inside of Google, a well-funded startup inside of Google, right? And I get to break all of our things and just kind of look at where the edges of our products exist and think about the customer experience for those products. I've been in the NLP space for about 12 plus years. I was doing chatbots when they were absolutely terrible. And so we've gotten a long way since the beginning of, pre-BERT days and pre-transformer days into where we are today now. Big contributor to the open source community as well, so if you want to talk open source stuff, holler at me. I manage a couple of different open source libraries here at Google, and then also I'm a contributor to the LangChain library as well. Okay, cool. Let's talk about generative AI agents. Kevin threw this statement up earlier, and I just want to kind of reiterate what we talk about when we say generative AI agents, kind of what we mean. So we roughly define a generative AI agent as an application that tries to achieve a goal by observing and acting upon the world using the tools that it has at its disposal, right? So again, you can just think of this as any sort of software application that is compiled of a few different components, again, to act upon the world. Think of maybe some of you may have written, Python scripts or things like that to interact with your Nest thermostat, right? Hey Google, turn on the hallway thermostat, or set the thermostat to 78 degrees, things like that. In a way, you're basically interacting with the form of an agent. The difference here today is that we're starting to kind of formulate agents in the realm of generative AI. So agents are able to reason and act and think upon the ideas that we give them, and then give them tools to interact with the outside world. So broadly, there are a few different ways that we find users categorizing agents. You can categorize them by modality and sort of by the model that they are interacting with. So you have large language model agents, maybe you have vision language model agents, and you can also have a mixture of these types of models and agents. You can also do use case-based categorization. So you might hear someone say oh, I built a healthcare agent, or I built a cybersecurity agent or a customer support agent, things like that. The word agent itself is absolutely overloaded. We've had agents since, human call center agents, right? Then we had virtual agents. Then we've got all different, we've got Agent Smith, right? Like in the Matrix. We've got all kinds of agents everywhere. Agents is definitely overloaded in the space. But if you're hearing the word agents today, and you're hearing the term agentic behavior, what we're really talking about is sort of generative AI agents. People are talking about LLM and RAG and those types of things. I like to break this down a little bit more simply and think about the interaction types that we have with our agents. So typically what we start to see emerge in the space is that we have conversational agents, which is sort of the predominant agent type in the space. And then we also have a lesser known version called workflow agents. Now, most of you are familiar with conversational agents. Why? Because LLMs you use natural language to interact with them, right? So it's easy to wrap your head around the concept of a chatbot, right? I'm going to do RAG, I'm going to talk to my website, I'm going to talk to my private documentation, right? There's a human involved sending a query to an agent. The agent is doing some magic behind the scenes, and then we're getting a response back. But where I really see the future going is this concept of workflow agents. Now, who's familiar with the concept of workflow automation that we've had for over a decade, right? Workflow automation has been a thing for a long time. Now imagine taking that same type of workflow automation from systems like, like Pegasystems or Automation Anywhere or Blue Prism and like those types of things that are doing RPA, but now powering them with LLMs, right? Powering them with generative AI. And so this is what the concept of workflow agents allows you to do, is like build these generative agent systems into your workflows that humans are not directly interacting with. So think about emails coming into an inbox, an agent is reading that email, categorizing it, formulating a response, and then opening a Jira ticket, and then doing something else. So no human involved there, but the agent is still doing some sort of task. And again, you might think, well, isn't that just regular old automation? And the answer is yes, it is. The difference is you're not writing as much code anymore, right? You're doing a lot of this using natural language with prompting and few-shot examples and things like that. Okay, so let's talk about the foundational components of an agent. Broadly speaking, we focus on these three primary foundational components of an agent. You have what is sort of your foundational model that you're using under the hood. You have the concept of tools that the model has access to so it can actually interact with the outside world. And then you have sort of the heart or the brain of the agent, depending on how you want to think of it, which is the reasoning loop. So sometimes we hear this referred to as a reasoning engine, or maybe the orchestrator, or the computer, or many of those different things. But this is really where kind of all the quote-unquote magic happens. Now, you might hear other people define agents, saying like, oh, they need these other 2 components, or they need these other 5 components, or you could technically take away tools and it's still an agent. And tomato, tomato, however you want to look at that, but this is essentially how we define agents and how we look at them today. So let's talk about each of those different components. So from the model's perspective, this can be typically any generative language model. It could be a small model, it could be a large model. You could use any of the Gemini stuff out of the box. It could be text Bison. You can also use multimodal models, so Vision Pro, things like that. Your own fine-tuned models. Also doesn't have to be Google models at all. You can do this with the Claudes and the GPTs and all of the different things of the world. Any sort of generative model you can build an agent with. The key thing to remember when you're looking and evaluating your models for what you want to put in your agents is that the training data in those models can play a significant role in the agent's long-term ability to be effective for your use case. Let me say that again. The training data that is in that model plays a large role and how effective your agent is at the use case you're building it for. So let me give an example. If you're building a use case for customer care, you want to make sure that there, inside of that model training data somewhere, there was some training data around customer care. Because if there's not data in there around customer care, that means you have to do more fine-tuning or add more few-shot examples or do better prompt engineering. So if you're working in a really niche vertical or really niche use case, there's probably not a lot of data about your use case out on the internet and the public web. So that means that these models probably don't have a lot of data about your specific area, your specific use case. So keep that in mind when you're choosing a model to build your agents, because if the data is not there, you're going to spend more time on the back end adding more examples, adding more data, fine-tuning, things like that. Tools. So the important thing to understand about tools is that, again, they allow agents to reach out into the outside world and interact with the outside world. So this isn't just reading, this is also writing. So it's not just, what is the temperature in the hallway? It's go ahead and also change the temperature for me, right? So being able to do that type of two-way interaction. At Google, we look at 3 primary types of tools. We have this concept of extensions, or vertex extensions, functions, or you might have heard of this as function calling, and then data stores. Data stores are essentially vector databases. We heard a little bit of that from both Kevin and Shobhak this morning. At the bottom, you can see that there are various different types of tools that can be used. This is just a very, very small portion of what you could consider a tool. Your agent reads Gmail for you. Your agent does Google search for you. You could even also think of a human as a tool for an agent. So imagine an agent workflow where something is happening, and then at some point the agent says, actually, I don't know how to solve this, so I'm going to ask my human to give me some additional input so then I can move on. So you can also use yourself as a tool. The last piece of the puzzle is the reasoning loop itself. So, the reasoning process inside of an agent is a very iterative, introspective process. The agent is actually thinking through every single step that it needs to do, the same way that you and I think through steps every single day. When you took a break just now, you went outside and you thought, man, do I want coffee or do I want that nice spa water, or am I going to have chips or gummy worms? Like, you were trying to figure out what decisions you were going to make, and then once you decided you were going to have coffee, you started using your tools to make your coffee and put all that stuff together. So as an agent, you're going through these same type of reasoning workflows in your head every day, every second of the day. And that's the same type of stuff that we're doing here with our generative AI agents. There are a few different frameworks that are sort of predominant in this space around how these reasoning pieces of our agents work. The number one that we see, and we heard this from Shovik as well, is like the React framework, which is reason and action. Kevin also talked about this as well. But you have also other concepts, chain of thoughts, tree of thoughts, graph of thoughts, stimulus prompting, lots of different frameworks you can use. There isn't a particular right or wrong way to do this. You can build an agent however it suits your particular business case and use case. But I would just say that React is definitely the most predominant one that we see in the space. You're probably going to find the most stuff out there on Stack Overflow. You're going to see the most quick labs around that type of stuff, and a lot of the papers are really talking about React a whole lot. Okay, the key takeaway to remember about the difference between models and agents, right? A lot of different things that I can say about them, but the main thing to remember is that a model is sort of limited or beholden to the knowledge that has been trained inside of it, right? So if you've ever played around with Gemini, ChatGPT, things like that, you might ask a question about, who was the president, who was the 20th president of the United States, something like that, right? It's a historical question, so it has that training data in it, and it's fine, right? But if you were to say, what time do the Braves play tomorrow, right? It might not have that information because maybe it wasn't trained with the latest schedule for Major League Baseball, right? And so the difference, again, is that the model has some set of world knowledge and training, but it can't look outside of that world knowledge. Whereas agents have the ability to reach out into the outside world and get real-time information and then reason and act on that real-time information. So let's talk about the basic operation of an agent itself. Again, whether you are using a conversational agent or a workflow agent, you have the concept of a user query or some sort of trigger event that's coming into the system. And then you go inside of your agent loop, all the magic happens, and you get a response. So for example, if I were to say something like, I want to book a flight from Austin to Zurich, what would happen inside of the reasoning loop is that the LLM would help the reason and action engine to sort of think through, okay, I want to book a flight. I should search for flights. I'm going to use this particular flight tool that I know that I have available to myself. These are the inputs for that flight tool that I'm going to get. Now the flight tool has responded to me with some API response, and I'm going to sort of think about what I just got. Okay, I should go ahead and summarize this and send it back to the user, and then I send a nice human-readable response back to the user, like, here are some flights that might interest you. So this is sort of a typical kind of one-pass loop through this system. Now inside of that green box, inside of that reasoning loop, that can happen n number of times. It doesn't necessarily have to be like, oh, I made an API call and these results were great and I'm just going to go back to the user. It could make an API call and the API might error out and it says, oh, hey, there's an error in the API. Let me wait 5 seconds and then try again. And then it tries again. Or maybe it gets the results and says, oh, that's way too many results. Let me add one more filter. So let me send a second API call. Now, there's no additional human prompting there. This is the agent itself thinking about how it needs to solve this problem for the user based on the query or the event that came into the system. All right, let's get through tools real quick, and then hopefully I can have some time to show a little bit of a demo. So we'll talk about extensions first. So extensions are, again, tools, remember, allow you to connect your agent to the outside world. So imagine that you are building an agent, and you have this Google Flights API that you want to connect to, but you're not really sure how am I going to glue these things together? How do I actually get it to connect to that system? Extensions allow you to do that and essentially give the agent full autonomy to make that extension call. Imagine this the same way you might imagine a software developer where you're saying like, hey, I know that we have a Flights API out there somewhere, Patrick. Can you figure out how to make that call? And I'm like, oh yeah, okay, I'm gonna write, I know I need to do this input payload, and when I pass this payload in, I'm gonna get some results back, and then, so I've figured out how to make this call. So anytime I need to search for flights, I'll just go ahead and use this API. So as a human agent, I can make that decision on my own, and so our generative AI agents can also make those same decisions. So extensions essentially describe the when, the how, and the what to expect about an API interface. So when the user wants to search for flights, use this thing. And when you do use this Google Flights tool, this is how you use it. And when it returns back, this is what you should expect. Now, there are several different ways that you can build extensions today. Most of the extensions are built upon the Open API specification. And I want to be clear that Open API is different from OpenAI. OpenAI is a company. Open API is a specification. This is a standard that sort of like the global industry has centered around. And this is a way to basically define API specifications so that they're both human readable and machine readable. You can define them in JSON. You can define them in YAML, things like that. And then your extensions themselves can be deployed in really any type of system. You could use a serverless system like Cloud Run or Cloud Functions. You could build a Flask application in Kubernetes. You could do it in Compute Engine. You could use AWS Lambdas. It really doesn't matter. The point is that you're building essentially a shim between the agent and the API interface. And that Open API specification defines that unity between those two systems, right? Okay. Functions or function calling. So imagine this scenario. This happens a whole lot in enterprise, right? Let's say that you're building an agent and you have this concept of an extension that you want to use. But then you also have this API or a BigQuery table or something that lives in like a super secret, secure GCP infrastructure, VPC that no one can touch except for like 2 people in the whole company. So how do you actually get that extension to make that call over to that system? So one of the things that you can do is instead of using extensions, you can use this concept called function calling. So what function calling does is essentially mock or stub out that API call, right? So it goes through the same process that the extension does, except it doesn't actually make the API call. So it's going to do the when and the how, but it's not going to do the what to expect because it's not actually making that API call. So what the agent does is it utilizes the function to drive the inputs to this API call, and then it hands it upstream to some UI or middleware system or some proxy server that does have permission to make this API call. That proxy server makes the API call to your super secret pizza BigQuery API, and then that responds back to the middleware, which can then respond back to the agent and sort of inform it about the response that happened. So this is a way to kind of get around these security measures. If your security team doesn't want your agent directly interacting with your super secret API, you can use function calling and go through proxies. So that's really a really nice thing to be able to do. A side-by-side that's also always a good thing to take a look at is the difference between function calling and extensions. So remember, extensions allow the agent to have full autonomy to make that decision and just call that API whenever you want. You know exactly how to use it. Functions, stubbed out, mock API calls essentially is what they are. So think about that. There's always a proxy involved with functions. All right, data stores, and then we'll get into some fun stuff. So we've talked a lot about vector databases already today. I won't go like super heavy into vector databases. The TLDR is we take documents, we take websites, we take structured data, all different types of connectors. We do some embeddings, we work our magic, it goes into a vector database, and then we allow you to interface with that by saying things like, you know, what colors does the Pixel 7 come in? So you saw this in Shovik's demo. So basically we're providing an embedding for that query of the user. We're doing semantic similarity search over the vector database space, and we're returning some top results. Pretty straightforward stuff. Now, the thing about doing this with generative AI agents is that you can take this kind of like RAG setup and add it to a multi-turn generative AI agent. So now agents can use these vector databases like vector search as a tool to be able to like search over your PDFs, search over your website, and things like that. So, you know, early on in the agent hype, so probably like mid to late 2023, there was a ton of RAG use cases coming out, and a lot of people were saying like, oh, I'm releasing this chatbot that is like talk to my website. Like that was basically some of the early agent stuff that was really coming out, was basically a simple RAG use case where we're just having a multi-turn conversation with our website. And so the ability to use extensions, functions, and data stores with your agents are the really powerful pieces of adding tools to our agents. We'll get your questions after the talk. So sample architecture, so just real quick, this is a really, really simple architecture that you might put together for an agent setup. You know, you might build a custom interface, maybe you've got a mobile app, a mobile SDK, you've got a web UI or something. Your agent is behind that UI. There's a model behind that. All of the tools are kind of connected behind the scenes. And then you have your various sets of APIs behind the scenes. And this is essentially how you could build an agent architecture. Right before the demo, I'm going to talk about some of the more complex multi-agent architectures. So there are really two predominant things that we've seen as far as multi-agent architectures. The first one is called a collaborative architecture. So this is essentially where you have, imagine these yellow boxes on the screen are those kind of embedded agent architectures that I was just showing. And you have a concept of like a messaging queue. So think of pub sub, something like that in the middle, where the user is sending a query. It goes into the messaging queue. That message is essentially distributed out to all of the agents. They play a little ranking game of, oh, I've got it better. I have a better confidence about this stuff. And then we'll say, okay, agent A picks up that thing, and it does its introspective process, and it responds. And when it responds, it goes back into the messaging queue. And that messaging queue might have a tag on it that says, respond to user, and then it sends back to the user. Or it might have a tag on it that says, agent D, you're next. And then it sends over to agent D. Or it might send it back into the queue and say, like, okay, this is up for bid again. Who wants to answer this next question? I did my part, right? The same way that we do on software engineering teams or product teams, you're like, I put my feature in. Who does this go to now? The program manager, the product manager. So think about that type of collaborative nature with a messaging queue in the middle. The other more common one that we see a lot is sort of this kind of top-down or supervisory agent. So this is essentially where you have a concept of like a steering or an orchestration agent at the top. So every single query is going to come into this orchestration agent, and then that orchestration agent is going to be able to kind of pass on these things to the sub-agents, right? And there could be all different types of end-to-end connections or one-to-end connections and things like that. So you can think of this more like a switchboard operator, right? Like the call is coming in, the switchboard operator is like, oh, that goes to extension 5000, I'm going to plug it in there, extension 5000, then can send it back to the operator or send it down to extension 6000 and so on and so forth. And again, each of these agents have the ability to interact with each other, interact with the outside world, different tools, and you can kind of set up however you want to do those particular systems. All right, let's get into the demo real quick, and I'll just kind of show you how we can work with some of our agents in Agent Builder today. Let's see, hopefully this is big enough. So I'm in the Agent Builder interface. Shovik was showing this earlier. Today what I'm going to do is just create a live application. So we're going to build a demo live because not only do I love doing live demos, but I love doing just like from scratch live demos. So we're just going to do it really fast so you can see like how everything works. In Agent Builder today, you can select different types of applications. So I'm going to select the agent application. We're just going to let it be called whatever we want to, the timestamp today. Okay, so when you land in this interface, you're going to be greeted with this sort of like blank slate interface. Now, if you've used LangChain before, if you've worked with agent chaining and things like this, essentially what we've done is built a really nice UI for you to manage your prompts, add your tools, connect all these things together, and even chain agents and chain prompts and do all this stuff in a nice visual UI builder. Now, I'm not going to do anything yet with that. I'm actually just going to immediately talk to the model, which is over on the far right-hand side. So behind the scenes, we've deployed all the infrastructure for this right now. If I wanted to deploy this to production, it's production ready. It's scalable. It's served by Google, infrastructure. Like there's nothing else that you need to do. There's an SDK. You make that call. You want to send 1 million requests to it right now. It is production scalable. So again, that's a really important part of this system is that there is nothing else for you to do. You can do development and you can push this to prod right away. So I'm just going to say, what models do you have? A very ambiguous question, right? And over here on the right-hand side, it says, we have a wide range of models to choose from. What type of vehicle are you interested in? So again, this is just world knowledge from the model, just trying to disambiguate my random question about the world. But now what I'm going to do is a concept called persona prompting. So in the goal box over here on the left-hand side, I'm going to give it a goal. I'm going to say, you are a friendly Tesla service center agent. Your job is to help answer user questions and schedule appointments. And then in the instructions, I'm going to say, greet the user, answer their questions to the best of your ability. Now I'm going to hit save, and I'm going to copy this query and restart my conversation. Live demos, here we go. Okay, what models do you have? We have the Model S, Model 3, Model X, and Model Y. Which one would you like to know more about? Now, all I've done is provided a little bit more surface area for the LLM and the agent to kind of understand who it is, right? So now it's not generically talking about cars. It's like, oh, I'm a Tesla service center agent. I need to talk about Tesla cars. I need to do these particular tasks. Like, this is what my job is. just a few lines of plain English, right? No code yet. And now let's take it a step further. Let's say, okay, my Model 3 is not charging. Where can I get this fixed in Atlanta? Now, we're sort of hoping for a hallucination here. Yeah, there it is. Okay, why am I hoping for a hallucination? Because this thing doesn't have any connection to the outside world right now. It's just telling me like, oh yeah, we've got a Tesla Service Center agent on Peachtree Road in Georgia. Let's go ahead and copy this, and let's open up maps so we can actually see where this is, because like we'll call BS on this agent, right? Oh, that looks like it's the corner of whatever's going on here. That's like the Capitol Grill, something. There's no Tesla Service Center here, right? Now, here's the interesting thing, right, is that if you didn't know any better, let's say you were asking it to write code for you, and it came back with a really great response, you'd be like, oh, wow, that was really cool. That was magical. Did you see how it knew that? It didn't actually know that. It was hallucinating, right? And so how do we manage these types of hallucinations? We ground our agents in reality. And the way we ground them is by giving them access to the real outside world. So here's what I'm going to do. On the left-hand nav bar, I'm going to create a tool. And so out of the box, we have a code interpreter tool, so our agents can code, but we're going to do a custom tool. So I'm going to do one called Places Search. And I'm going to say this is an API that allows the agent to look up points of interest in a city. And then what I'm going to do, so I don't have to type out this entire YAML spec, because I'm going to copy it from another agent, and I'm going to paste it here. But just so you can see, this is what an open API specification schema looks like. It's basically defining what are the inputs to this API and what are the outputs that I'm going to get from it. And so what this is going to be connecting to is the Google Maps or Google Places API. And so I'm going to save that. I'm going to go back to my agent, and I'm just going to add one more line. If the user needs real-time information about a city or place, use tool Places Search to answer the question. And then I'm going to hit save. And then we'll go through this flow again. Let's see, what models do you have? And we've got that, and I'm going to say, okay, where can I get this fixed in Atlanta? Now, we're either going to have something go wrong, or it's actually going to magically work. And here, it magically worked. So we can see here that without any other further prompting except for one additional line, the agent decided, I'm going to actually call the Places Search tool. And you can see here that the input was preferences, Tesla Service Center, City, Atlanta. And then if we take a look at the addresses that come back, these are actually coming back from the Google Places API. Let's take a look at a couple of them real quick, just to make sure that these are Tesla Service Centers or something similar to it. Let's see here. Zoom in there. Oh, and there it is. There's a Tesla Service Center, right? Cool. So why? Because this is actually coming from real data in the real world. It's not making this stuff up. Now, the cool thing about this interface is that let's say that I like everything that's happened so far, but I want to sort of tune or kind of train my model to do a little bit more for me. Let's say I don't like the way that it had a really wordy response. So what I can do is click on this playbook button for default generative. I'm going to select my entire conversation, and I'm going to create a few-shot example directly from the conversation I just had. So I clicked on Save Example. I'm going to give this a name, just example 1. And the thing that I want to change is this last response. So there are 2 Tesla Service Centers in Atlanta, and what I'm going to do is I'm just going to delete this piece, and I'm going to add a bullet point there, and I'm going to delete this and add a bullet point there. And then I'm going to go back into the response. And so you'll notice now it's going to format it for me like Markdown. But I'm going to go back into the response, and I'm going to look, because we also have the ratings in there. So what I'm going to do is just add the ratings in 3.9 rating and 3.3 rating. I'm just going to type that in there, right? And so now my few-shot example basically looks like this, okay? So I'm going to go ahead and hit Create. And then I am going to go back to my interface. Let's see, back here. And now I'm just going to ask a very direct question. Where can I get my Model 3 fixed in San Francisco? And this time, based on the prompt and the tool and the few-shot examples, it knows that it can call that same tool for San Francisco this time, Tesla Service Center San Francisco, real API call, and it knows to do the formatting that I asked it to do and even include the star rating over on the right-hand side. So, in a few short minutes, we were able to build an agent from scratch. Obviously, doing demos like this is fun and fast and easy. Production is a lot harder, and there's a lot of things that happen in production. Connecting to your real-world data can take a lot more time. But the takeaway here is that this is accessible. We have democratized AI to the nth degree, so that any of you in the room that can speak, talk, type English, French, Italian, German, Spanish, any language, you can now essentially program your agent without really adding any code at all, just a little bit of YAML, and that's what we have software engineers for. So with that, that concludes my demo and my presentation today. Feel free to connect with me on LinkedIn if you have time. I know we're probably just a little bit over, but I'm going to see if I can take a couple of minutes for maybe let's do 2 questions if anyone has them. Oh, yes, ma'am.
If you have, I know you don't have too much time, but are there any general guidelines, yardsticks, because you spoke a lot about the training data being really important for the model. How much data, quality, quantity, are there any yardsticks, guidelines?
Yeah, so the question is how much, are there best practices or guidelines for how much data that you need inside of your models? So for, I would say 99% of the use cases, you don't really need to worry about it at all. These models have a ton of training data in it. What you should be more worried about is sort of the fine-tuning edges, so the few-shot examples that I showed. So being able to add somewhere between 3 and 5 examples per agent flow or agent use case is about the sweet spot for best practices. If you find that you're adding 20, 30, 50 examples to your agents, you need to think about your architecture. You're trying to do too much in one agent. So you need to split that agent apart and think about, okay, can I break this up in such a way so that this agent has about 5 to 6 examples and is doing a very specific task and can pass on to my next agent and so on and so forth. Now, if you do happen to be in that 1% category where there is no data on the internet about anything about your model and you do need to do a fine-tuned model, you can get away with about 100 high-quality examples. And what I'm talking about is think about the use case that you're trying to build. You want to put together 100 high-quality examples that you're going to give as fine-tuning training data to that model so that you could then use that model in your agent downstream. Now, let's say you didn't do the fine-tuning data. That just means you're going to have to add way more few-shot examples to your agent, right? So you either do the work up front or you do the work on the back end. Depends on your appetite for kind of modifying these things and what you can do from a software development perspective. We'll do one more question. Anyone? No? Cool. You, sir.
When you're using orchestration, because you didn't quite show any of that, do you use other Google tools for that, specifically? Because you also mentioned internal to Google, external. Are there any limitations with how this would interact with networking?
Yeah, so the question was, when we're doing the orchestration piece, do we use tools internal to Google or external from Google? How do they interact with each other? So when you're looking at systems like I just showed you, which is Agent Builder, that is a managed service. So we are using React for that service behind the scenes. We've already built in the orchestration. You don't have to think about that at all. But let's say you wanted to DIY this. You could DIY this with Gemini SDK, LangChain, and Reasoning Engine, right? And then with Reasoning Engine on Vertex, you could deploy various different types of architectures for orchestration. LangChain does zero-shot prompting, multi-shot prompting, React, chain of thought. So basically, the sky is the limit. And even if you use a managed service like I just showed, you could still build a tool to call other agents with other types of frameworks out externally. So really, it's all about how you want to orchestrate your application and what you're building. Cool. All right, thanks, everyone. We're going to have another speaker coming up next.